The term stored program control concept refers to the storage of instructions in computer memory to enable it to perform a variety of tasks in sequence or intermittently. The idea was introduced in the late 1940s by John von Neumann, who proposed that a program be electronically stored in the binary number format in a memory device so that instructions could be modified by the computer as determined by the intermediate computational results. ENIAC, or the Electronic Numerical Integrator and Computer, was the first computing system designed in the early 1940s. It was based on the stored program concept in which machine use memory for processing data. The stored program concept can be further classified into three basic ways. 1. Von Neumann model. 2. General purpose system. 3. Parallel processing.
We are about to discuss the von Neumann model, proposed by mathematician and physicist John von Neumann in 1945. This model has significantly influenced modern computing, providing a robust framework that supports the development of complex software and hardware systems, characterized by its stored program concept, where both program instruction and data are stored in same memory space, allowing for greater flexibility and efficiency in computing. The model consists of several critical key components. First is the control unit. This unit directs the operation of the processor and manages the execution of instructions. Second, the ALU, or the arithmetic and logic unit, responsible for performing arithmetic and logical operation. Third is the registers, small, fast storage location within the CPU that hold data and instructions temporarily during processing. Fourth is the memory, a single memory space that stores both instructions and data. And lastly, input-output devices. These allow the computer to interact with the external environment, facilitating data input and output. Next, the characteristic of von Neumann model. First is a single processor. The architecture typically employs a single processor to execute instructions sequentially. Second, unified memory. It uses one memory system for both instructions and data, which simplifies the design and enhances efficiency. Third is the fetch, decode, execute cycle. Programs are executed through a cycle where instructions are fetched from memory, decoded to understand the operation, and then executed by the ALU, or the arithmetic and logic unit. This cycle is fundamental to how computers operate under the von Neumann model, allowing for systematic processing of tasks. Thank you.
The von Neumann structure is the basis of modern computers. It includes central processing unit, which contains control unit and arithmetic logic unit to process instruction. Data and progress instruction are stored in the same memory unit. Input device bring data into the system, and output device display results. These structures allows for sequential execution of tasks, forming the core of today's computers. Computers of von Neumann model: central processing unit, control unit, registers, buses, and memory unit.
Processing units that we call CPU. The central processing unit is the core of component of a computer responsible for executing majority of data processing operations. It essentials an electrical circuit process instruction from the computer programs, performs from functions from based on the type of instructions it receives. The major components of the CPU is arithmetic logic unit, number 2, the control unit, and register. The CPU ability to perform the complex calculations and logical operations makes operation a critical component of the computer system, enable everything from the simple tasks, application.
Control unit. The control unit of a computer system controls the operation of components like ALU, memory, and input-output device. In this part, the control unit is a vital part of a computer architecture. It manages and coordinates the activities of the computer various components, such as the arithmetic logic unit, memory, and input-output device. The control unit interpret instruction from program and generate control signals to ensure that all parts of the computer work together efficiently. The control unit consists of a program counter that contains the address of the instruction to be fetched and an instruction register into which instructions are fetched from memory execution. In this part, the control unit includes two key components, the program counter and the instruction register. The program counter keeps track the address of the instruction that needs to be fetched from memory. One, Once the instruction is fetched, it is stored in the instruction register, where it can be decoded and executed. This process ensures that the CPU process instructions are in correct sequence, allowing the computer run program effectively.
Registers. Registers refer to a high-speed storage areas in the CPU. The data processed by the CPU are fetched from the registers. The following is the list of registers that plays a crucial role in data processing. Number one, we have MAR or Memory Address Register. This register holds the memory location of the data that needs to be accessed. MDR or Memory Data Register. This register holds the data that is being transferred to or from the memory of the AC or accumulator. This register holds the intermediate arithmetic and logic results. PC, which stands for program counter. This register contains the address of the next instruction to be executed. And lastly, CIR, current instruction register. This register contains the current instruction during processing.
Buses. Buses are the means by which information is shared between the registers in a multiple register configuration system. A bus structure consists of a set of common lines, one for each bit of a register, through which binary information is transferred one at a time. Control signals determine which register is selected by the bus during each particular register transfer. The von Neumann architecture, comprised of three major bus systems for data transfer, consists of the address bus, the data bus, and the control bus. The address bus carries the address of data, but not the data, between the processor and the memory. Data bus carries data between the processor, the memory unit, and the input and output devices, while the control bus carries signals or commands from the CPU.
Memory unit. A memory unit is a collection of storage cells together with associated circuits needed to transfer information in and out of a storage. The memory stores binary information in groups of bits called words. The internal structure of a memory unit is specified by the number of words it contains and the number of bits in each word. There are two major types of memories are used in computer systems. One, RAM or random access memory, and two, ROM, which is read-only memory.
Ang general-purpose computer system is basically a more advanced version ng von Neumann architecture. Think of it as a modern-day architecture for computer. It's like a city, but in computer form. Super high-tech, organized, and efficient. At the core of this system is the CPU, Central Processing Unit. The CPU is like the city office where everything important happens. Within the CPU, we have ALU, Arithmetic and Logic Unit. Think of this like a math and logic department. Sila yung mga geeks who handle all the calculations, decision-making processes, and control unit. Think of this as the boss. Siya yung nagsisigurado na everything running smoothly, giving instruction to the rest of the team on what to do and when to do it. Plus, the CPU has a processor register, which act like a notepads where temporary important info is stored. Processor registered ay mga small storage unit sa loob mismo ng CPU para sa mga temporary and immediate needs ng computer while it's doing its work. Now connected to the CPU is the memory unit. Imagine this as the city huge library or storage warehouse kung saan nakasave lahat ng information that the CPU needs to do its job. And then we also have the input and output subsystem, which is like the city communication. This handle all the info going in and out of the system tulad ng when you type on your computer or print something. Yes. How they all communicate. There's this thing called system bus, which is like the super highway connecting all the major areas of the city. The data line where information flows from one place to another. And then we had the address lane. Address lane where it's like on base, making sure data goes to the right destination. The control lane acts like a traffic light, making sure everything moves orderly manner. Walang sabit, walang bangga, walang kahit anong sagabal. And some system, hindi lang isang bus ang ginagamit for more efficiency. Merong multiple bus architecture. Imagine mo meron pa more than one super highway so mas maraming data ang kayang dumont at the same time. This setup is designed for high true performance, meaning it can handle a larger load compared to the usual single bus. Sobrang bilis and walang gusot. And that's basically how general purpose computer system work. Everything is interconnected and super efficient.
Parallel processing. Parallel processing can be described as a class of techniques which enables the system to achieve simultaneous data processing tasks to increase the computational speed of a computer system. A parallel processing system can carry out simultaneous data processing to achieve faster execution time. For instance, while an instruction is being processed in the ALU component of the CPU, the next instruction can be read from memory. The primary purpose of parallel processing is to enhance the computer processing capability and increase its throughput, i.e., the amount of processing that can be accomplished during a given interval of time. A parallel processing system can be achieved by having a multiplicity of functional units that perform identical or different operations simultaneously. The data can be distributed among various multiple functional units. The following diagram shows one possible way of separating the execution unit into 8 functional units operating in parallel.
Operation performed in each functional unit is indicated in each block of the diagram. Processor registers the first adder, subtractor, integer multiply, logic, unit, shift unit, incrementer, floating point add subtract, floating point multiply, floating point divide. The adder and integer multiplier performs the arithmetic operation with integer numbers. The floating point operation are separated into 3 circuits operating in parallel. The logic shift and increment operation can be performed concurrently on different data. All units are independent of each other, so one number can be shifted while another number is being incremented.
Classification of computers. Flynn's classification of computers. Flynn's classification, proposed by Michael J. Flynn in 1966, is a way to classify computer architectures based on the number of concurrent instructions and data stream they can process. The classification includes 4 categories. First is a SISD or single instruction stream and single data stream. This is the most basic computer architecture where a single processor executes a single instruction stream to operate on data stored in a single memory. This corresponds to a traditional uniprocessor system where instructions are processed sequentially. Okay. Yung Flynn's classification, sa Flynn's classification, ang SISD o single instruction stream at single data stream ay tumutukoy sa isang uri ng computer architecture kung saan ang isang processor lang ang gumagana para mag-execute ng isang instruction sa isang data stream. Ibig sabihin po nun, ang system ay gumagawa ng mga operation ng sunod-sunod. Example, example po dito is yung traditional personal computers. Ang traditional na uniprocessor system tulad ng mga unang personal computers ay gumagamit ng isang processor lang po para isagawa ang lahat ng mga process. Ang processor po na ito ang tumatanggap at nagbibigay ng output para sa mga task na ginagawa ng computer. Ito din po yung usual na disenyo ng mga lumang computers bago pa nauso ang mga multiprocessor at multi-core processor system. Next po is SIMD o Single Instruction Stream at Multiple Data Stream. In SIMD, a single instruction control multiple processing elements that execute the same operation on different data points concurrently. This is useful for tasks like image processing or scientific simulations that require the same operations to be applied to large datasets. Sa SIMD po o Single Instruction Stream at Multiple Data Stream, isang instruction lang ang nagkocontrol sa maraming processing elements na sabay-sabay na perform ng parehong operation sa iba't ibang data points. Useful din po ito sa mga tasks tulad ng image processing o scientific simulation kung saan kailangan ang parehong operation ay ma-apply sa malalaking datasets. Example po dito is vector processor, parallel processor, at GPU. Ang vector processor po, ito ay mga processor na idinisenyo para mag-manipulate ng mga vectors ng mga one-dimensional arrays data lang po. At ang parallel processor ay may kakayahang magsagawa ng maraming operation ng sabay-sabay gamit ang iba't ibang core o processing units. At ang GPU po ay ito po yung mga specialized processor na idinisenyo para sa graphics rendering pero ginagamit din ito para sa general purpose at computing task. At yung pangatlo po is multiple instruction stream at single data stream. In this rare type of architecture, multiple instruction operate on a single data stream. This could potentially be used in fault-tolerant system where the same data is processed by multiple processors for error checking and reliability. Halimbawa, sa SIMD, ang parehong operation ay maaaring isagawa sa iba't ibang data points ng sabay-sabay. Maaari itong gamitin sa mga fault-tolerant system kung saan ang parehong data ay pinoproseso ng iba't ibang processors. Sa ganitong paraan, kapag may nangyaring error sa isang processor, maaari ring umandar ang isang sistema dahil may ibang processor na nag-check at nagpoproseso ng data. Example po dito is yung mga pipeline computers. Ang pipeline computer ay mga sistema na gumagamit ng pipeline processing para mapibilis ang pagpoproseso ng data. Halimbawa, habang ang isang instruction ay nag-evaluate, ang susunod na instruction ay nagpa-fetch ng data at ang isa pang instruction ay nagde-decode. Para sa isang assembly line kung saan sabay-sabay ang mga gawain para makuha ang mas mabilis po na resulta. Next po is MIMD o Multiple Instruction Stream at Multiple Data Stream. This architecture allows multiple processors to perform different instructions on different data at the same time. It is the common architecture in modern systems, especially in multi-core processor and distributed computing systems. Ang architecture po na ito ay tinatawag na multiple instruction at multiple data stream o MIMD. Dito po maraming processor ang pwedeng magsagawa ng iba't ibang instruction sa iba't ibang data ng sabay-sabay. Ito ang pangkaraniwang architecture sa mga modernong sistema lalo na sa mga multi-processor at distributed computing system. Example po dito, ang multiple core CPU po ay isang uri ng processor na may higit sa isang core o unit na pwedeng magproseso ng mga utos ng sabay-sabay. Ang multiple core CPU po ay isang uri ng processor na may higit sa isang core o unit na pwedeng magproseso ng mga instruction ng sabay-sabay. Dahil po dito, mas mabilis at mas epektibo ang pagtakbo ng mga application, lalo na ang mga nangangailangan po ng maraming resources tulad ng gaming o video editing. Para isang team, para isang team na nagwo-work po o nagpa-process sa iba't ibang gawain ng sabay-sabay. Kaya mas mabilis ang resulta kumpara po sa mga single core CPU. Ang supercomputer ay mga makapangyarihang computer na idinisenyo po para sa mga complex na calculation at advanced data processing. Madalas itong ginagamit sa mga scientific research, weather forecasting, at simulation ng mga natural phenomena. Dahil kayang-kaya nitong magproseso ng mga malalaking volume ng data na napakamabilis na paraan.
Computer registers. Registers are a type of computer memory used to quickly accept, store, and transfer data instructions that are being used immediately by the CPU. The registers used by the CPU are often termed as processor registers. A processor register may hold instruction, storage address, or any data, such as a bit sequence or individual characters. The computer needs processor register for manipulating data and the register for holding a memory address. The register holding the memory location is used to calculate the address of next instruction after execution of the core instruction is completed. Following is the list of some of the most common registers used in a basic computer. Data register holds memory operand. Address register holds address for the memory. Accumulator process register. Instruction register holds instruction code. Program counter holds address of the instruction. Temporary register holds temporary data. Input register carries out input character, while output register carries output character. That's all.
As you can see, I will be shown the register and memory configuration of a basic computer. First, the memory unit. The memory unit has a capacity of 4096 words, and each word contains 16 bits. And next, the data register contains 16 bits in which hold the operand read from the memory location. And also the function of the is holds the data being transferred to or from the memory. And next is MAR or memory address register. And also it contains 12 bits which hold the address of the memory location. And next we have the PC or the program counter, also contains the 12 bits which hold the address of the next instruction to be read from after the current instruction is executed. And next we have the AC or the accumulator register is general purpose processing register. Next is the instruction read from the memory is placed in the instruction register or IR. And the next is temporary register or TR. And it used for holding the temporary data during the processing. And next we have the IR or the input register. And it also holds the input characters given by the user or it holds the input data received from the external devices. The output register holds the data and holds the output after the processing the input data.